All right, this is kind of rough, but for those of you who are still working on the essay of how energy plays a role in plate tectonics, listen closely. Here we have a picture of the whole Earth. In the middle, we have the core. In the middle, we have the inner core. So there's inner core, outer core. Anyway, so there's energy in this core, right? The energy is transferred into the mantle in the form of heat. So this is heating up the mantle. And when this happens, the molecules are doing something. Snapshot. The molecules are moving further apart and moving faster. Because they're moving further apart and faster, they're becoming less dense. Rewind. Now, back to the mantle. If it's less dense than everything around it, it's going to rise. And as it rises, it's transferring energy out to the mantle around it, right? So as it's transferring energy out, the molecules are becoming more dense and closer together, which looks like this. More dense, closer together. All right? Now, they cannot sink back down just because they're becoming more dense, because the mantle under it is pushing up. So instead of going down, they get pushed out to the sides. As the mantle's traveling under the crust or lithospheric plates, it's dragging the crust. All right? It's dragging the crust. So eventually, it's going to find a spot where it can sink because it is more dense than the mantle under it. So it sinks, and as it gets closer to the core, the whole thing happens again. It gets heated up by the core. Molecules move faster, further apart, becomes less dense, begins to rise, goes up, can't go anywhere, so it pushes out to the sides. It's dragging the lithospheric plates. It becomes cool. Molecules move closer together. It becomes more dense, sinks back down toward the core. This repetitive cycle, because of the heat and cooling of the molecules within the mantle, is called convection currents. All right, so energy creates convection currents, which moves the lithospheric plates. That is what you need to include in your essay.